Hey everyone, this is Baylor, and in this very quick video, we are going to look at the basics of starting building a dependency injection container or an IOC from scratch. This is unscripted. I hope it goes well. Please be patient because I'm not the best typer when I'm tired. So it's a good time to make a video. This is basically what we should walk away from that. So what I've done is I've created a new solution. It's really simple. It's got two projects. The test project will be NUnit, and I've structured my test so that I have a base class, and then every method will have its own class. It'll actually have test fixture on it, and I just name it so it's underscore with the method name. So the first test that we want to have is a very simple one where we want to be able to just build an instance of basically transient. And yeah, so what we'll do is we'll have a subject, and here we're going to say we have container.getInstance. It's grabbing this. We don't want that, so we'll just ignore that for now. And the way we'll do this, we'll just say we want a type of A. And so what I'm thinking here is that we will have a class called A. Doesn't really matter what's on the class. But what we will have, and for this we'll just put this as A, and then what we'll do is we'll say that we expect subject to, or should, be instance of, be of type A. There we go. And so this is complaining because we haven't added this container class, so we'll add that real quick. It'll be type of container. And we'll just do that real quick. So we're going to say we get an object, and we get that from saying get instance, and we hand it a type. And for this, we're just going to turn null just so we can be certain this is failing. And what I also need to do is add a reference to that project. And perfect. And this we can remove that, and we'll actually just cast it on this side. There we go, perfect. This is not happy. Can't be used. Oh, so we need to create that. So I have, well, I guess this will be protected. We'll have a container, type of container, and I'm just going to very simply just set up some before and after methods. And so these are just in-unit hooks. And actually what I'll do is this, make it a field. Perfect. So the way that I'm doing this is that before each and after each, these run after and before each test. And so I'm saying before we're going to create an instance, and after we'll set that back to null. And that'll ensure that we don't have carryover between the tests. And so this should fail because it is going to be null when it should be a type of A. And we did. We got null, and we expected it to be an instance of A. So what we can do here, we can't actually use this, right? Because this is a private class inside of this other class, inside of another namespace. It's not added as a reference, so it's just a long list of why we can't do that. What we'll do instead is we're just going to say we want to have activator, create instance, and we're going to hand it the type. Now, this alone should probably tell you how this entire IOC works. And because of that, I encourage you to, if you want, to try to build the rest of this by simply going off of what you see here, because this is basically everything we're going to use to make ours work. I have not actually looked. If I was going to start a new project, I would use a thing called structure map. But because it's a tutorial on how to do so with C#, this is what we'll use. And I did something horribly wrong. I wanted to run the unit test. Okay, it passed. I guess I debugged it, whatever. It doesn't really matter because we can come in here and say, that we can create an instance, can initialize a new object. Perfect. So what we want to do now, this is not perfect, and it's not perfect because we can't construct, this is actually with no params. Yes. Okay, so we will actually construct this with parameters now. And so we'll just say we have a do test creates an instance with params. And what we'll do is we'll say for subject, and this time we're going to do another subject that'll be of type of B. And what we expect here is we're just going to have class B. It's going to have a public instance of A. And the way we get that is by saying that we have B takes the type of A equals A. So great naming here. Definitely going to win some award here at whenever people give awards out for programming. We expect subject to A to be of type A. So this should fail, and what we could actually do here as well is just give this a parameterless constructor. That way this can still pass, right? Because our activator right now, it just gives a new instance of a type with no constructors. So this will give us something here, but this should still be null. So if we run this test, we should get an error. And we do, because we have null and we expected A. So what we'll do here is now we need to really get into this. We need to actually inspect our type. So we're passing in type of B, and we need to look and see its constructors here, which we'll see A, and then for A we need to activate that as well. And so we can do that inside of here. What we'll do is we're going to ask for the constructor. And so here we'll just say type.getConstructors. And this is, we're just going to say first or default initially. This will give us the constructor that hopefully we're looking for. In this case, it's not going to work, right? Because B, the first constructor, is the parameterless version. We could say last or default. Really, we probably just want to stick with first or default. And the way we'll get around that is say we want to order this descending. We'll take that constructor and we'll say we want to order by the parameters length. And we do that descending so that we get the one that has the longest number of parameters. And what we can do here is we can say that we want to build a list of arguments. And that's because it's activated create instance. If you looked at this, you'll know that the second argument here, while I guess it can be binding flags, it's also a params array of args. And so we'll just say that our arguments are equal to the constructor. What we want to do is get the parameters again. So over the same method we'd use to get the parameter length, this time we'll actually get the parameters. And what we're going to do is just select these params. And we're just going to say we want to get an instance on this parameter.parameter type. And we'll map this to an array. And pass those args in. Okay, cool. So what this ends up doing is we hand it a type. That type, we find the constructor if it has one. If it doesn't, then we probably need to do something else, but we will look at that in another test. And that's a good point that for this, we'll probably actually say first, just because that'll help us find these problems as they arise. And then once we have that constructor, we get all the parameters. We basically go over each parameter's type and we pass that into get instance. So that'll help us find an instance. We map that to an array and then we call activator create instance with that type and we pass in those args. So now that should fix both of these tests. And it does? Question mark? Does it? It does. Success. So what we can do now is commit this, create instance with params. I guess that's with dependencies, but I don't want to spell dependencies in the video right now. I feel as if, though, that could cause a problem. So this helps us create params. What we also want to do is we've already somewhat confirmed, actually, yeah, we've already confirmed that we have the one with the longest args. We should, I guess that worked. Interestingly enough, I feel as if, though, we have a problem here because this constructor, this class doesn't have any constructors. what do we do if we have a constructor with no args? How do we handle that? So we need to create another class here. Class C. What we'll do here is we'll just put in bool invoked. How about that? That works. And here we'll just pass in C and we'll set invoked equal to true. And what we'll do is we'll just say it allows a parameterless constructor. And subject will be a type of C, container.get instance, and we'll hand it type of C. And subject.invoked.should be true. And we will run it. And this, I'm expecting this probably to fail, but I'm not 100% on that. It does work. Well, that's great. So we've confirmed that. Guess what? We're going to commit this again. Allow parameterless constructors. Perfect. Okay. So let's also do one more for this, and then we'll move on to something else. We have get instance where we pass in a type. It would be nice to be able to allow generics. That way we don't have to cast it every time. So void, it allows generic initialization. I think I spelled that correctly. Don't look too close. We'll just say container.getInstance. But this time we're going to give it type of A. We're going to go back to that and say subject dot should be of type A. And we don't have that yet, so we'll just create that method. This time we actually have a type. I wonder how many times I can do that over and over again. Get instance type, no arguments. And here we're going to return, we're going to cast it as a type, get instance for our type of type, or type of T. So when we run this, we should get a passing test. I know this isn't red green, and I apologize. I'm giving you bad lessons here whenever I am the one making YouTube videos, and I'm teaching bad practice. Just don't do what I do. Do what I do without doing what I do exactly. How about that? I'm sure I'm the first person to say that. Absolutely certain of it. I allow generics in when creating instances. Okay, so this is the easy part. I think it's easy part. As you can see, it's not very much to this. The things that we have problems with is we don't have a way to register types. And that is a critical part of IOCs. So what we'll do here is we will add another test fixture here. This will be another class, container, and here we're going to say register container test space. That way we have access to our instance of container when we need it. And what we'll do here is register a type from an interface. This is where, like, what we're doing here is we're piggybacking on the ability of us knowing the type. So we're saying, give me a type of A, but more realistically with an IOC, you're going to say, give me a type of I something. So what we'll do is, wow, I can't think very fast. I'm afraid of what I may choose here. We will say it's an I material. And for that, we're going to have, I don't know, what would my material have? Weight, maybe? We'll just do weight as an int because all weights are ints, probably. Every weight should be an int. No more floats. Get rid of them. We'll have a class of plastic material it inherits from. And it'll have a public int of weight. And for this, I don't know. What do you think weight is? 42 something, probably. And we'll have a class of metal material. And this will have a weight of 84. That'll be good. So this will allow us to say that when we ask for a type of iMaterial, we don't want it to try to instantiate iMaterial. We want it to instead use plastic. So for this, what we'll do is we're going to have some way of saying container register. And here we're going to say, for when you ask for an iMaterial, I want you to give me back any plastic. And now when I say my subject is equal to container.getInstance of iMaterial, we want subject to should be type of plastic. So we need to add this register method. So we shall do that now. It'll be register. It takes in tn. We have atout. I don't know of a better way to name that, but right now it's going to be a no op because we don't do anything. What we should actually get is an exception thrown because you can't instantiate interface. At least not yet. In 2018, that has not been added to the C# spec. Yeah. Invalid operation sequence contains elements first. So there's no constructor. This is maybe an example of why we should, even though it's a horrible test, right? Because this is not the test to discover that we have a bug with our first, but we will ignore that since that's not the point of this video. We're not trying to build a robust IOC here. So how do we want to do this? When we register something, we want to be able to say get back whatever the type is that is registered. And so what we'll do for this is we're going to have I'm trying to think about a good way to do this. We're probably going to have a private dictionary. It will be read only. This time I shall use what writer tells me. This will be a type, and it will be some type of way to activate that type. And the way I'm thinking about doing this is just saying that it gives us back an object. How about that? So we'll have registered types, and that'll be equal to in a dictionary, and I will let you complete that for me. Thank you very much. So what I'm thinking here is that most IOCs let you register types as a function. Could also be an expression, but I think function is probably fine here. And what I'm thinking on this is that if we just give it two types, then we're going to fall back to this. Even though I am planning a little bit ahead, I think this probably makes the most sense. So here what we'll do is we're just going to say our register types dot add, and here we're going to say our type of tn so that we create our key, and our value will just be something like get instance for our type of tout. There we go. So what this will allow, we don't care how we construct this tout or the type for our output, right? We're just going to fall back to our activator get instance or create instance, but it does allow us to customize how we find that. So we're changing the in of this. However, this does not solve this particular problem of when we get an instance, how do we actually find that? And so what we'll do is for our first step is we'll say that if we have a register types contains the key of our type, then what we'll do is say return register types dot for our type, and we'll initialize that or call that method. I think that is probably a fine way to handle that. I would feel a bit more comfortable running all the unit tests around this, but I think that will do it. It does. If that doesn't make sense, let me try to explain that again. All we're doing is we're basically creating a dictionary that has our types that are our inputs. So in this case, we're saying when we have iMaterial, what is our output? In this case, it's plastic. And so I decided to actually store that output into a function. It's not actually invoking this code. It's only storing the way to actually create this instance. And since we are only giving it a type, that means we can't just call new on it. Rather, we need to fall back to the way we're calling create instance. And then so what happens here is the first check we do is if we have that as a register type, then we invoke that getter basically, which then falls back to get instance, and then it goes through the whole chain. That means that we should be able, and we'll add that here. Add registered types. And so that means that we should be able to also say that we want to have load or initialize object with dependencies. So here we'll register iMaterial again. This time we're going to register something different, like I don't know, what something depends on plastic. A toy. How about that? Even though that's not really material, we will think of all toys as material things. How do you like that? Material. Really, what I probably should also do is say that whatever the T out is, it actually has to inherit from T in. That would look like this, right? That will help. That way, like if I try to do this, this fails right now. I'm not allowed to try to register type because it doesn't inherit from TN. Do I require that? You know what? That's probably like a realistic thing. I'm not so sure I like the idea of doing that here. However, and the reason for that is 100. I don't know. The reason I don't know if that's such a great idea is there might actually be some edge case where you actually register some faux type and you get back some instance that you actually do care about. I don't know. I can't think of a true edge case for that, but that is a possibility that you don't actually care about the type. But what we'll also do is, so when we have our toy here, we're also going to say this toy requires plastic. So it'll have a type of plastic. It'll be its material. How about that? And then I'll just have a getter on it, and we'll say that we have a public toy. Toy takes in a type of plastic. And that in this case, we want to just say our material is that bad? For this one, we're actually going to say it's plastic as our material. The reason I'm afraid is I don't want to see what happens. I imagine I'm not going to gracefully handle recursion very well, or an infinite loop. So we register iMaterial for our toy, and now we say our subject is equal to container.getInstance of iMaterial. And here we should be able to say subject dot, and we're going to actually cast this as a toy. Subject.material should be an instance type of plastic. And what I should probably do is make this, well, it should be equal to null by default, but we'll just do that just to be on the safe side to always ensure that we call that constructor correctly. So if we run this now, we get an object with dependencies. Yay, this is very good. So we will just say add test to confirm load initialize dependencies with registered types. Okay, so that's the last one that we'll do for this. I can't really, I guess what we could do, I'll leave this as an exercise for you as the viewer to go through and add, how do we allow a user to specify a function, and then we store that as a register type so that rather than trying to create an instance on our own accord, we use whatever the user wants. I think you're going to realize that's pretty straightforward. But that is up for you, because what we care about now is actually having singletons. Test fixture, public class, container, register, singleton, container, test base. Okay. Test public void. It returns a single instance So what we need here is some type of thing. We'll call it a pet. And we don't really care about what the pet is. We just need a pet in this case. And so we'll say container register singleton. Oh my goodness. For some reason I can't believe how I get to the point where I can't actually do that. But anyways, this will be our pet. Var pet equals new pet. Our subject is going to be equal to container.getInstance of type pet. And now what we do is we say subject dot should be instance be equivalent to. Well, this is where my fluent assertions knowledge goes right down the toilet. I cannot remember for sure. I think it's equivalent to, or B. Equals implementation. Okay. Versus equivalent to. I don't know. We'll try this one first. And the way we will confirm this is not working is by very simply saying, actually I'll put this up above, where we have public void register singleton. We take in a type of T, and this will just be an object. Actually, we'll say T of object. And this is no op to begin with. This should still work, right? This should, because we've already confirmed our IOC is the best. It does a great job. It gives us our instances. This should fail. Expected subject to be. Thank you. Wonderful. So I think this is it trying to tell us that they're not the same instance. We can confirm this be equivalent to. This I expect to pass, even though it would be wrong. But I just, for my own sanity, I think we'll just say that it works. If it doesn't, we'll figure that out in a second. But I'm mostly certain that what we're about to do will confirm this working. Okay. So what we want to do is we want to, well, what I'm actually thinking about doing is saying that we can piggyback off of register types for this. So we'll just say register types.add type of T, and we'll just actually use object here. So that will actually probably solve this, which is actually kind of cool that we've created a way to, by using generics, we've created a way for us to just expand upon this system without having to introduce any new concepts here. And so, yeah, I think that actually might be the best way to do that. Just because we've already confirmed that this works, we're piggybacking on this. If this ever breaks, then the whole thing breaks, which should actually give us a more robust system long term. And so for this, we will say that allow singletons to be registered. I know you're thinking, well, how can we trust this actually works whenever we weren't able to prove that B is to B? And I apologize for that, but I think you probably trust me at some capacity to know that we changed the method signature, or we changed the method, we got a new result, changed it back, and now this is all working. I guess what we could do is say pet2 here, new pet, and put 2 here. And we actually expect this to fail now, right? Because we very clearly have 2 different instances of pet. And as you can see, it fails. So that means it works. So you are welcome for that. I think actually, on a more serious note, I think this is it's not perfect, but it is more complete. We can register types that are not of the same actual implementation, right? We have an interface on one hand, we get different types. We can register singletons so that we always go back to the same instance. We can get an instance off of a generic type. We get an instance off of type, and we find the constructors. Didn't add a test for this, but I think that's probably fine. We have all passing tests. With that said, if you like this video, please subscribe and like it. It does really help the channel, and I do appreciate it. If you have any questions, please leave them in the comment section below. That always makes me feel good to get comments. Yeah, and so I think that's the end of this video. Thank you for watching, and I'll see you next time.